All right, so the last example that we have here is dividing complex numbers. How do we divide them? So I have a 3 plus 4i, and I'm dividing it by 5 minus I. What I'm trying to do is somehow divide these numbers so that I get an answer that just looks like another complex number, a plus bi. And so this one's a little tricky. So the first thing we have to talk about is what is a conjugate. A conjugate. We didn't talk about this in 4.5, but this is an important concept. A conjugate. So when you have a binomial, let's just say you have x plus y. You have some two-term polynomial. A conjugate of this x plus y would be x minus y. These would be conjugates of one another. And there are some special properties of conjugates that when you multiply conjugates together, and you could try this for yourself, but when you multiply them out, you have a lot of cancellation happen. It actually cleans up. It helps us do some algebra, essentially. So this is a conjugate here. So if I were to say 5 plus x, the conjugate of that would be 5 minus x, right? So that's just the idea or definition of what we're calling this conjugate, okay? So we're going to use that idea. So in this problem, I have 3 plus 4i, and it's divided by 5 minus I. The only way to algebraically divide these numbers is to multiply by the conjugate of the denominator. So right here, I'm looking at this 5 minus I in the denominator, and I'm thinking about, okay, well, first of all, what is the conjugate of 5 minus I? We'll look back to what we just talked about. The conjugate has to be 5 plus I, right? So what I'm going to do is I'm going to take the bottom and multiply it by 5 plus I. And we're going to see what happens there, right? So this is going to help us basically simplify this problem. I'm going to get this out of the way. It's going to help us simplify this problem. So watch what happens when I take 5 minus I times 5 plus I, its conjugate. So we go ahead and we multiply this bottom. Well, I'm going to have 25, and then I'm going to distribute. So I'm going to have plus 5i minus 5i, and that's where the cancellation is going to happen. See? So we're going to have plus 5i, but then immediately we're going to have minus 5i, which is going to completely cancel off itself. And then to finish this off, I'm going to have minus I, or negative I times positive I. So negative I times I, and so we get negative I squared, so minus I squared. So you can see what happens is that 5i minus 5i, this is going to cancel, right? That goes away. And if you remember, I squared is equal to negative 1. So when we talk about negative I squared, that would be like this is plus 1. That's 1 because you have negative times negative 1. So on the bottom here, you would have 25 plus 1. This would be a 26. Now on the top, you have to do the same thing, right? You have to multiply by this conjugate on the top, and really nothing special is gonna cancel off. You just have to start multiplying it out. So when we do the top here, we'll have 3 times 5, so we have 15. And then 3 times I, so we have plus 3i. And then we have 4i times 5, which is 20, so plus 20i. And then the last terms here, 4i times I is 4i squared, so plus 4i squared. And so now when we simplify the top, we're going to have we're going to have 23i, right? So I'm going to put that over here, 23i. And when we talk about the numbers, we'll have 15 plus 4i squared. Again, I squared is equal to -1, so 4 times I squared is equal to -4. So really I have 15 minus 4 here. I can combine this and this, and that's going to give me 11 plus 23i, and then all divided by 26. So there's my answer. I'm going to write it again down here. 11 plus 23i divided by 26. And really, what I want to do is make this look like a plus bi. So it's not really in that form yet. So what we can do is we can divide each term on the top by 26. So I could write this as 11 over 26 plus 23 over 26 times I. And there's my final answer in this form of a plus bi. So this is definitely a little bit more complicated problem. We start with what is a conjugate and how is that useful in this problem. Conjugates are used in a lot of different algebraic situations. So we multiply this bottom by the conjugate. That totally gets rid of everything except some number. And then you do the same thing to the top. And then make sure you write it in a plus bi form. So let's try some more of these. All right, and here's a practice problem for you where we're dividing two complex numbers again. So 1 minus 5i divided by 4 plus 7i. You can go ahead and pause this video, see if you can do it. And I'm going to go ahead and show you the answer. So if we want to divide these, we have to multiply by the conjugate of the bottom. We're trying to get rid of that I on the bottom of this large fraction. So I'm going to multiply this by 4 minus 7i on the bottom. And that should, let's see what that gives us. This will be 4 times 4, which is 16. And then we're going to have minus 28i and then plus 28i. If I multiply minus 28i and then plus 28i as I multiply those terms together. And then the last term I'm going to have is 7i times negative 7i, which is negative 49, or minus 49i squared. Okay, so the same thing happens in the other problem where these 28s are going to go away. And I'm going to have 16 minus 49i squared. I squared is equal to -1. So really this is negative 49 times -1. And essentially that's just positive 49 here. So really on the bottom of this fraction, we are getting 16 plus 49. And so we'll have 65 on the bottom. So the bottom becomes just 65. Now the top, we have to multiply by the same thing, 4 minus 7i. So we're going to go ahead and multiply all that together. So we're going to have 4, and then, let's see, minus 7i, and then minus 20i. And then I'll have plus 35i squared. So again, looking at the numbers, 35i squared is equal to negative 35 because I squared is equal to -1. And so I can add these things together. I can say 4, I have the 4 minus 35. And so that's going to give me a negative 31. And then I can combine my like terms with these i's. I got -7 and -20 for a total of -27. So minus 27i there. Okay, so now I'm going to bring it down. I really have my answer. I'm just going to break it up into 2 separate chunks here just to show that I have complex number. So I have -31 over 65. And then minus 27 over 65 times I. So there is my complex number. If you ever get into a situation where you can then reduce these fractions even further, right? Then of course you can reduce those fractions and put it into reduced form.